We went over problem 24 in class, but it doesn't hurt to talk about it again because it's using substitution. So for this particular problem, we can set u to be y plus 1. Therefore, du is y plus 1 takes derivative times dy since 1 dy, namely dy. So du is dy. Therefore, the original problem is y multiplied by 4th root of u dy, where dy is du, so the problem is u to the 1/4 and then du here. Well, the only problem is that I still have y here. I cannot carry out my integration if I have two variables involved. So I need to get rid of this y and make sure it's in terms of u. Well, by looking at the original structure, I realized that y is simply u minus 1. So I could change my problem into u minus 1 multiplied by u to the 1/4 du, which means it's u to the 5/4 if I FOIL things out, minus u to the 1/4 du. So it is 1/5/4 plus 1, that minus 1/1/4 plus 1, u, my bad, 1/4 plus 1 plus c. But of course, this is not good enough. You do need to rewrite your u back into the original structure, and then you can copy paste the other pieces so as to get your final answer, right? So this is one way to solve it. I'm not 100% sure if we can have another way, so actually just for the sake of discussion, we can have a try, see if another way would work out. So the particular problem we got here is, sorry, I'm running out of spaces, is this. So, well, I could try something else just for fun, see if it works out. So if I have y plus 1 to the power of 1/4 to be my derivative, therefore du is 1/4 y plus 1 to the power of -3/4 and times derivative y plus 1, which is 1, and then dy. So just by looking at this expression, I'm going to end up with, well, integration of y, and then 1/4 of y plus 1, which is u, and then I have a dy. Well, my dy is supposed to be du divided by 1/4 y plus 1 to the -3/4. So I can like clean things up a little bit. It's 4, it's y plus 1 to the power of 3/4 du, which is dy, and then what I end up with is y plus 1 technically to the power of 1/4 is u, hence this is u cubed, du equals dy. So my problem is now 4 u cubed du, right? All you want to do is to make sure your expression only have u in it other than constant. So having y is a little bit problematic. Well, I still need to get rid of this y, so if I look at the original connection, I'm going to end up with u to the power of 4 is y plus 1. Therefore, u to the power of 4 minus 1 is supposed to be y. So my problem can be phrased as u to the power of 4 minus 1 multiplied by u multiplied by 4u cubed du. Well, it's not too bad. U to the 4th, u to the 3rd, so it's 4u 8th minus 4u 4th du. So for this problem, I can find the antiderivative relatively easily. 4/9 u to the 9 plus 4, minus 4/5 u to the 5 plus c, where u is y plus 1 to the power of 1/4, so it's 4/9 y plus 1 to the power of 1/4 times 9, which is 9/4, minus 4/5 u, my bad, I can't use u, y plus 1 to the power of 5/4 plus c. So this is one way to set up the calculation, and clearly both methods works. I do want to comment that if you have this expression, it's equivalent to y plus 1 to the power of 1/4 cubed. therefore it's the same as you could. So I did have two different ways to solve this problem, and they should be giving you the same final answer.